Welcome back, folks. We've talked a little bit about power. I think we should maybe take a step back and talk about energy for a little bit. And talking about power, and we're going to do that here. I call it stupid units of energy. There's a lot of units of energy floating around that aren't the SI unit. Take a second while I'm talking. Think about what the SI unit for energy is. Hopefully that comes to you quickly. You should have seen it in previous classes. But we're going to call this video Stupid Units of Energy. Okay? So power that we were talking about, I'm trying to do this for every value and variable that we work with. The unit of power is the watt. Okay? Again, named after somebody, so it gets a capital W. And it gets an alternate unit as well, because we were talking about the fact that power is work over time, or energy over time. So we can think about the alternate unit as well if we know the unit of energy. And hopefully by now you've remembered that it is the joule. Okay, so we might talk about power as joules per second. Okay, capital J over lowercase s. Okay, so power, and our variable for power is capital P or lowercase p. I don't have a fancy way to make the lowercase p look like a lowercase p. Maybe I'll figure that out if I need to. Usually it's a function of time, so you can see that it's a function of time and assume that it's time variant. So that's power, and energy is measured in joules, or at least it should be measured in joules. But a lot of times you're not going to see that. Go look at your power bill. I should bring up a copy of my power bill just to make you cry, because I heat my house with electricity. It was the early 70s when this was built, so it was a crazy time. I wasn't there. Anyhow, so if you go look at your power bill, your energy consumption is going to be measured in kilowatt hours. Okay, so your electric company is going to use the first stupid unit of energy. It's not the stupidest unit of energy. I have a winner for that one too. So the electric company, okay, Eversource, or what used to be CL&P, or Alabama Power, or wherever you're listening to this, whoever generates your electricity for you, measures energy in kilowatt hours. Okay, so the kilo, we kind of know what's going on there, but watt hours is strange. It's almost related to joules. It's almost there, but not quite. Power, of course, is let's see, it is the amount of work done over a period of time. So if I look at the unit here, let's see if I can make some room here and maybe grab a different color. If I look here, the unit is joules because it's in work, and that's energy. And the unit down here in time is seconds. And that's how we end up with joules per second up here for the alternate unit for power. But if we take power and we multiply it by hours, okay, and we multiply it by hours, then it's not quite going to cancel the way we want it to. There's this extra factor that we have to deal with. So looking at the units, so let's look at the units for this type of thing. And if we're looking for kilowatt hours and we want to get it down to energy, then let's see. So for power, it's going to be joules per second, okay, times hours, and that's what gives us, not a kilowatt hour. This just gives us a watt hour. Okay, so there's another factor in there because of the prefix. Okay, so watt hours equals joules per second times hours, and these don't cancel nicely. But this is how your electric company does it. So I don't know of any that measures it actually in joules. It would be nice if they did. These don't cancel without an extra factor. Okay, if I wanted to make those cancel, I would have to consider, let's see, watt. If I want to get it down to joules, right? And I have joules per second, and I'm multiplying by hours. This all becomes kilowatt hours. And if I want to make these cancel, then I need to get rid of hours in the numerator. So I'm going to divide by hours. That's a horrible H. Let me fix that for you. And I need to multiply by seconds, but I need to not change this value, so I need to multiply by something that's equal to 1. So 1 hour is going to be 3,600 seconds. Okay, so I have this extra factor of 36 hours. So if I take watt hours, not kilowatt hours, if I take watt hours and I multiply it by 3,600, I'm going to end up with joules. Okay. Now, if you account for the kilo and you take that in and you use it as part of your value for watt hours, then you can just multiply by 3,600 and you're good to go. Okay, that's why the prefix becomes part of the number. Try to work with the base value, base units whenever we can. Okay, so it's a unit of energy. It's not an SI unit. It is power times time. So it makes a little bit of sense, but why are we adding this additional factor of 3,600 needlessly? The answer is convention, and probably had something to do with how meters were constructed when electricity was first being distributed. I'm not really sure. There's probably a good history lesson there if you dig into why electric companies use kilowatt hours instead of joules. Okay, not the worst unit of energy, but let's do let's do a short example here. Okay, to figure out what's going on. So an air pump, it's summer right now, and I was playing with a bouncy house because you do that when you have kids, and I wanted to know how much the bouncy house cost to run for the better part of a day. So I looked at how much power was being dissipated by the bouncy house, and I took a guess at how long I was going to run it. So the air pump for a bouncy house, I should get a picture of the bouncy house for you. For a bouncy house, an inflatable, whatever they're called, uses 750 watts. And you might be tempted to say 750 watts of energy, but it's not energy. Okay, be very careful. Watts is a unit of power, and we want to get back to energy. Okay. Let's see if it runs. Let's say we're having a good party, as if we can have parties nowadays. If it runs for 6 hours, how much energy does it use? Okay, so as simple as it gets, we get for this type of problem, but I want you to get used to following your units whenever you can. How much energy does it use? Let's start out by finding out how much energy it uses in kilowatt hours. That question mark's getting kind of close. It's the only fun I have nowadays. I'm sorry. Okay, so 750 watts and we want to figure out how much work we're going to do. Okay, how much energy we're going to spend. So work and energy is W, and we're going to take power and we're going to multiply it by time. And let's leave it in watt hours to begin with, and we're going to end up with 750 watts, and we're going to multiply it by 6 hours. Okay, I realized I do have a calculator, although it's kind of a silly calculator. Thank you, Windows. So we can hopefully get this on screen so that you can just watch me punch it in. I'm not sure why, but I will try to get, although I will try to get a good TI emulator or something for you as the calculations become more complex. Okay, so we have 750 watts, and we run it for 6 hours. We're going to get 4,500 watt hours. Okay, so performing that calculation, we get 4,500. There you go. We're going to pause the video for that one. Okay. Sorry about that. 4,500 watt hours. And now my alarm's going off. It's going to be that kind of day, folks, but you're going to get this video anyways. Hold on. And we're back. 4,500 watt hours. And we could also express that in kilowatt hours, right? 4.5 kilowatt hours. If we are being good and strict about using engineering notation. Okay, so 4.5 kilowatt hours, and then we can go figure out what our rate is. It's probably around 20 cents nowadays, and figure out how much it cost us to run the air pump for this bouncy house for 6 hours. Okay, but that's not in joules. It's not in joules, and you know, if we're being good engineers and we want to work with SI units whenever we can to avoid confusion, then we should really figure out how to get this back out to joules. So how many joules of energy are we using to run this bouncy house for 6 hours? Which is different than the amount of energy that my kids expend when using the bouncy house for 6 hours. Completely different things. You got to talk calories for that one. Okay, so if we're starting with 4.5 kilowatt hours, we have to think about that alternate unit for watts, because watts is joules per second, right? So 4.5 kilojoules per second times hours, and we want to get rid of as much of this stuff. 4.5, the K is part of the number. I really want you to start thinking about that. That is 4,500, okay? Just like it was up here. Okay, I'm going to treat that as part of the number. And I want to get rid of this mismatch between hours and seconds. And just like I mentioned above, I'm going to multiply by 3,600 seconds per hour. And then the hours are going to cancel, and the seconds are going to cancel, and I'm left just with the unit joules. Okay, so I have to take 4,500, and I have to multiply it by 3,600. Okay, 4,500, and I multiply by 3,600, and I get a nice big number, 16,200,000. Okay, oh gosh, I'll write it out. 16 million, that's a comma, 200,000 joules. Okay, and here's why we use SI prefixes, because that is 16.2 megajoules. Okay, stupid unit of energy, kilowatt hours. Not the worst unit of energy. I think I'm going to leave the next one to another video, and I'll do the stupider unit of energy for you, and I have another example for that one. Okay, so I'll probably give you a couple little web work questions about this, and then pop over to the next video so that you can learn about the stupider unit of energy. I know you're excited. I am too. Okay, so stay tuned and good luck.